Walter here at Crystal Instruments. Last episode, I showed you guys how to carry out a modal test using a modal hammer. In this episode, I'm going to show you guys how to carry out a modal test using a modal shaker. Shaker tests use a modal shaker to excite the structure. By using multiple reference signals and multiple response measurements, this creates a matrix of FRF signals. This is referred to as multiple input, multiple output MIMO testing. The structure is excited at multiple fixed degrees of freedom, and the responses are measured at multiple DOFs. If the dynamic signal analyzer does not have enough input channels to cover all the measurement DOFs in one shot, we can rove the measurement sensors over the structure. The measurement can be repeated to finish all the required response DOFs. Modal shakers are driven by an amplifier which receives an output signal from the dynamic signal analyzer. Many waveform types are available to drive the structure under test. Commonly used waveforms include pure random, burst random, periodic random, and pseudo-random. The support structure must be set up before the test. The test object is freely suspended with soft bungee cords. Once the support structure has been set up, the modal shakers must be attached to the structure via stingers. Before starting the data acquisition, the structure's test point mesh must be defined. An array of test points has been marked on the structure. This mesh of points has also been predefined in our ADM modal software prior to today's test, so we simply need to load the mesh file. Now let's begin configuring the modal software. Start ADM Modal and open the new test wizard. Here you can see a list of modal test types. Choose MIMO FRF test and follow the remaining steps of the test wizard. This is the first part of ADM Modal, the geometry editor. This is where we define the dimensions of our structure. Models are constructed based on test point IDs. In this tutorial, we will load a predefined model. Press the folder button to load a model file. After opening your model, move to the input channel setup. Configure the input channels with appropriate sensor parameters. Make sure that the measuring point IDs are assigned to the correct channels, as well as increment number for roving. Now click on the Output Channel Setup tab. Here you can configure the output signal types. We must enable both output channels, and we must set the output type to burst random, or other types of output, depends on test requirement. The next tab is called Scope. This is a live signal display for checking instrument status. You can make sure that the sensor channels are working correctly and that the drive voltage is sufficient. When you're ready, move to the MIMO FRF measurement page. This is the interface that is displayed during measurement. The signal displays in the middle of the screen are preset to certain signals, but these can be adjusted by the user. There is a list of live signals on the left part of the screen. These can be dragged onto the existing signal displays or can be created in a new signal display by double-clicking on them. Now let's configure the testing parameters. Press the Config button. The signal analysis parameters are shown here. Set the frequency range, block size, overlap ratio, and averaging settings here. Press OK when finished. Now the test is ready to be started. Press the Run button in the control panel to start the test. Live data is displayed for each of the signal displays. When the average number is reached, the test will stop. Now we must move the sensors to the next set of measurement points. We need to do this because we don't have enough input channels and sensors to cover the whole structure in one run. We need to perform multiple measurements to acquire all the data. Now that we've moved the sensors to a new location, we are ready to measure the next set of data. The measurement DOFs have automatically been updated to the new locations on the structure. We must repeat the measurements until all the testing points on the structure have been measured. Once we've measured each testing point on the structure, we can proceed to modal data selection, band selection, stability diagrams, animation, and operation deflection shapes. You can view your acquired FRF signals in the Modal Data Selection tab. From here you can manage and view individual measurements. This is the list of signals which will be used for analysis. Add or remove signals to the list by right-clicking on individual measurements. You can drag signals from the Data Files tab on the left part of the screen. You can also import and export signals with the dedicated buttons on the bottom part of the screen. This concludes part 3 of our modal tutorial series. Stay tuned for part 4.